My name is Ebrahim Balouji, CEO, founder of EcoPhi from Sweden. What we do is, as titled here, is AI-driven substation automation. A bit about background EcoPhi, how it's started is we are academic spin-out from Chalmers University of Technology. Since 2014, we have started the activities, and we have headquarters in Sweden, office also in United States. Alongside the way, we were recognized in Sweden with prominent rewards, such as SCAPA reward that you see there. But how it started is the story goes back to the research time at Chalmers University. We asked our boss, what do we do as a research? He said that we don't know. And that started going to the utilities by utilities. What are the problems, pain points, so that we can help out basically and do the research on the topic that can contribute directly to the utilities. And looking to the globally, what are the problems as well? We saw that there is a limited visibility and delay insight to the utilities. What's going on in the substation most often is blind. And that leads to a fragmented monitoring and so on. And the grid is getting more congested. Outages are one of the biggest problems, and complexity is growing. To the point that, for example, in the United States, the worst nightmare cannot be more than outage. The cost of outage in the United States is reported more than $150 billion, globally more than $300 billion. To avoid this, we need to modernize the grid, digitalize it. And if we go with the conventional methods of putting relay and everything in every feeder, it's going to be needed to be spent more than trillions of dollars, $3 billion, to renovate it. And also smart grid solutions like PQ meters and so on, they are expensive. That's why it leads to a fragmented monitoring of the system. Therefore, we developed QMU 800, which is the merging unit that we have, has the highest sample rate in the market. With 2 million samples per second, we can sample voltage and current. And it has one of the highest resolution as well, 24 bits per channel. We sample the voltage and current according to IC 61850 or 61869. This enabled us to virtualize applications like PQ monitoring, partial discharge, metering system, and some protection functions. All of them, they are basically placed in CMPC 100, which is the hardware that we basically Advantech is help us to provide to the customer. And the solution is deployed in both transmission, distribution, and generation and industry. It's not limited to any voltage level. A bit more resolution to the merging unit is that it can connect to all type of sensors. If you want to connect to CTVT conventional, you're going to use a CTVT card. If you want to connect it to LPs, low power CTs, Rokowski coils, you can use Rokowski coil. And we can monitor PD, and also there's other applications like power quality monitor and so on, can be deployed in it. And this is CMPC 800, which contains the virtualized applications, such as power quality monitoring system, PMU, and so on that I just mentioned. And that is basically a bit of a detailed in the architecture, the way that we deploy this if you want to redundant fashion. This is a bit more detailed. Suppose that you have, for example, a substation with 4 feeder. By the way, one single merging unit in this case scenario can cover all merging unit, but to just the sake of presentation, if the number of feeders are growing rapidly, you can use even 2 SIM cards to monitor redundant. And QMU 800 has already built-in GPS. You don't need to buy GPS. It can publish timestamps according to IEEE version 2 PTP protocol, and directly can go through the switch to the CMPC 800, which you saw the hardware of it, and there we deploy everything in the edge, simply virtualization of PMU for power phasor measurement units, power quality according to IC standard class A, and PD monitoring and DFR system, and can be other applications like if you have from other vendors, centralized protection or anything, you can deploy it there as well. And then this enables us to detect any abnormality, anything that is happening in the voltage and current. With the tiniest detail, we can capture them and we analyze them. Once we analyze them, we can predict the failures and potential, what's going to happen within a week. For example, we have predicted so many faults together with the help of our sister company, Energyot. This is a bit even more detailed, how the system works. Basically, QMU 800 can publish sample value, optional 4.8, 14.4, 28.8 kilohertz, any sample value that you want, it can publish. Even up to 2 million samples per second we can go. There is no limitation there, according to IC 61869. And this is the inside of CMPC you see, that we have a sample value subscriber, and it can also connect to the GPS master clock to be able to publish the sample values. And then there we have used Seapatch to virtualize our applications simply. That all of the applications that you see here, they are containerized and put in the VM and sits there. And it's extremely easy, flexible to scale them up. If internet allow me, I will do a demo too. It's a bit of a shaky situation. This is our dashboard. Once you virtualize all of the applications, you can concentrate the data in one single united place. And this is, you see the applications, all of them, they are listed here. And this is the overall dashboard, what's going on, energy losses, where are the critical points in the system. We can do all of this. We can do all of this, offer all of this analysis. Partial discharge monitoring in an online fashion without any sleep time, with a trend analysis in the substation. We do. You can see there. And when I say no sleep time, it's everything is in real time. Also, at the same time, classified why this PD, for example, is happening with the trend analysis and everything. So if you want to, for example, deploy online-based PD protection, the setup is already there. It's not like conventional PD monitoring that there is a sleep time, 1 second to sleep, 1 minute to sleep, 1 hour to sleep, and then continue recording. It's continuous. And then virtualized power quality. As I mentioned, we measure voltage and current and every parameters that IEC standard class A requires to monitor. We monitor everything. Frequency, power, sag, swell, interruption, everything. With the even more tighter threshold than what standard requires. For example, standard says that you need to trigger and record if the voltage level goes below and above 5% of the nominal value, but we record even at 1%, even tiny transients, interruptions, and all of them is being recorded. And then phasor measurement unit, according to class M, or class P can be available upon the request to monitor voltage and current, again, amplitude, anything that you want, frequency of the system, rock-off, angle of the system. All of them has been available here. And then there are other applications once you know, for example, the health of the system based on the PD, the capacity of the system, what's going on, or for example, you have GIS information and everything. You can, I forgot the metering. So thanks to the accuracy of the measurement that we have, we can also turn all of the metering devices as a virtual application as well, measuring the active power, reactive power, and apparent power, anything that needed. When it comes to capacity, I was talking to about, if you know the partial discharge, power quality, high frequency issues, low frequency issues, and GIS information, you no longer need to install, for example, a thermometer to be able to do capacity analysis. You can do everything in a real time, online, know what capacity this transformer has, both transformer rating and line rating you can do. And from that, you can also drive fault prediction, as I mentioned. For example, our sister company drives this, use the data that we provide to be predicting the failures. To the root cause, for example, we say that this is a timeline you see in this particular feeder, that there's going to be a failure in the transformer. With the explainable AI, anything that we predict is going to say that why we're predicting such a high value. With the location, for example, this one is another one that is happening because of the insulation degradation, 2.4 kilometer. With the meter accuracy, we can predict the failures, that where it's going to happen, and that helps to reduce the SIDE. So this is basically overall summary of the software. So based on the practical data and practice deployment that we had, we have managed to, for example, for the utilities, reduce the operation maintenance cost up to 20%. Downtimes, the failures that has been predicted, we managed to avoid 67% of all of the faults, 90% of the predictable faults, and deployment of such a system that you see merge unit plus centralized or virtualized applications that you saw. It can reduce the copper cabling cost. It can reduce the smart grid cost deployments like power quality and so on by 60%. And no additional hardware needed for PMU, power quality, and all of that, because first of all, it's been turned into software. Second is that for example, if you want to upgrade according to new standard, you don't need to upgrade the hardware anymore. You just need to upgrade the software. And with the accuracy of the measurement and 2 megahertz sampling rate, in overall calculation of the substation building cost, it can be reduced by $1.5 million, and reduction in operation maintenance by 30%, and so on, with the explainable AI. We have had around 200 deployments of this system, and 400 more projected globally, some of them in Sweden, some of them in United States, Middle East. These are the basically area of focus for us, and we are expanding, growing rapidly over the time. I tried to keep it short. If there is any question, I will be more than happy to answer every single one of them. You were first.
Yeah, on the slide you say protection, but on the function it doesn't say any protection function. So does it protect, or is it coming?
We have minimalistic protection functions like overcurrent protection and earth fault protection, but there are some activities that we are doing. For example, we are doing this protection line differential over 5G in Saudi Arabia. So there are some functions that are getting more added, but you don't have to, for example, buy the protection from us. You can buy from other vendors, for example, ABB or other. Then you can deploy for example, inside the CMPC, or it can be even possible to deploy with some tweak and cheek inside of QMU as well.
Yeah, so with the predictive fault analysis that you have, with what level of granularity are you able to see, for example, the substation. It's all very similar voltage level, lots of different base, lots of different switchgear. What level of granularity are you able to say, well, we'll predict that there's going to be an insulation failure on this type of equipment?
You mean the accuracy of the location?
Yes.
With the meter level accuracy, we can say that the fault is going to happen here because of this reason. Like we have had the case that, for example, thunder hit the line, damaged the transformer, and tap changer was not working fine, and we highlighted that that transformer is going to be failed. Or for example, when we say insulation degradation is happening and there's going to be potentially failure because of that, we say the location is going to be here. Because we have 2 megahertz sample rate, early things that, for example, early intermittent cases that are happening, we can see how they're traveling and so on. Through using these methods, we can locate them early on, and then also the location of faults comes from that. Much more straightforward. Yes?
Prediction, you said that 90% of accuracy for prediction.
What you saw, 90%? I highlighted that 67% of the total faults, 90% of the predictable faults. For example, that was a result from the actual site that I was reporting. There are some places that they are even more higher and lower. There are some faults that, for example, if someone digs the ground with excavator, nobody can predict that. Or if thunder hits the line, it creates a fault, nobody can predict that. But the wear and tear and the things that are, for example, happen because of the operation of the malfunction, or something has generated bad in the factory and so on, they are started to show some signs, we can catch them. And they are usually, this type of percentage of the fault from utility to utility different. Some utility has 80% of the fault are predictable based because they are old. Some utilities, they have 50%. So this is what it is, for example, when I say the percentage of the faults. There is a site that we have covered almost all of the predictable faults. It's no false positive, by the way. Any more question? Yes?
Yeah. The AI model you said for fault prediction, is it a generalized model that can work for any type of grid, or is it specific to any type?
No, it is generalized model. We don't need to do a retraining to every single voltage level events, because we are using voltage and current as a source of information. We don't use other sensories that can vary from system to system.
And the fault prediction accuracy that you mentioned, is that applicable for distribution and transmission?
Yes, we have deployed it in the distribution and transmission and in the industry.
Second question, where do you get this example frequency can go up to 2 megahertz? I mean, as far as I know, the standard doesn't specify any standard frequency at that level of version.
No, it doesn't. But standard also leave your hand open. It doesn't say that you can't do that either. So standard says that, for example, these are the recommended sample values. You can go 4.8, this, 90, 96, 200. It goes like this with the multiplication. But it doesn't block your hand that you can't have a 2 megahertz sample based 2 megahertz sample rate. So, yeah. But again, packaging and everything is according to standard. There's no homemade solution there. Yes. Any more questions? Okay. Thank you so much for your attention.